we're still working on that. The objective for today, and I didn't write this on the board. I didn't write it on the Promethean board, but I want you to write down this objective, which is use dimensional analysis. We're gonna write this down. Use USE. Do you need to go somewhere else, young man? Yeah, you're good. Okay, use dimensional analysis to convert a value from one unit to another. I'm going to say that again several times so that everyone can get it written down. And the title of this is Unit Conversions or Dimensional Analysis. I'm going to say it again. The objective is use dimensional analysis to convert a value from one unit to another, which I forgot to write the word one, but I'm going to write it now. Good thing I left myself plenty of room. Use dimensional analysis to convert a value from one unit to another. The title is Unit Conversions or Dimensional Analysis. What's a unit? What is a unit? No, I don't want an example. I want you to tell me what is a unit. What is the definition of a unit? Will? Okay. A way to measure specifically. Do you have a problem with that definition? Do you? Because you made a comment about it. Me? Yes, you. No. Okay, good. Let's not make comments then. Yes, I know it is. Let's think of it. That's a good definition, Will. What's another definition for unit? You know you have to use units, right? Well, I mean, some of you are learning that, but you have to have units with almost every number. I say almost because there are some dimensionless quantities. A unit is a little label that we give to our measurement so that other people understand how we measured it. That's a pretty basic definition. If I say that I'm too tall, not T-O-O, let me use a different. If I say I'm 6 tall, you probably would know that I was meaning 6 feet because we're immersed in a culture where that is the common standard of measurement. But that's not a great way to say it. You usually, even you who don't put your units on your numbers with your bell work, will say things like, I'm 5'2" or whatever you are, right? You still use units without even knowing about it. When you're in Mr. Jones's class, and he says, hey, how long is that board? You don't say, oh, it's 13. You might, but you probably say 13 inches. I would guess you use units. You're supposed to use units. They're a way for us all to agree upon how we're measuring things. What does this word conversions mean? What does it mean to convert something? To change. So we're probably going to be converting in this lesson from one unit to another. In fact, I'm going to tell you, not just probably, that is what we're going to be doing. Lord willing. We're going to convert from one unit to another. We also call it this, in chemistry and physics, we call it dimensional analysis. What's a dimension? A dimension is kind of a slightly, there are other definitions for this, but in one definition, the definition we're talking about, it's a kind of fancier word for measurement. It's the dimensions of something are the measurements of it. Yep. The dimensions of this keyboard are probably about 25 centimeters by about 10 centimeters. Those are dimensions. Does that make sense? Dimensions are slightly, Chloe, please pay attention. Dimensions are a slightly fancier way of saying measurements. There are other definitions of the word dimension, but that's what we're using. And then analysis means to do what? Yeah, analyze. It means to analyze. It means to look at something and study it and think about it. Why would we ever want to do this? Why do I think this is important? I'm not asking you why do I think it's important. Why might I, in your opinion, think that it's important to be able to convert from one unit to another? Yes?
If I was not able to do this, I would not be able to build the shed in my 7th period class.
I'm gonna have a trouble with that. Well, I appreciate what you're getting at, and I find that to be true. The rhetoric you're espousing is true. However, I think you'll find that there are very many carpenters and people in woodshop class and others plumbers, electricians, who do their entire job without ever knowing how to do this. So that's not quite it. It is useful, but it's especially useful in science, where we might be using different units from one person to the next, but also from one trial to the next. And sometimes the units that we use when we, for instance, add them up, get too cumbersome and we want to change units. So here's how we do it. And you're going to write this down because this is extremely important. There are a different set of steps from the way we solve formula problems. What we've been doing before with volume and density, are formula problems, where we have a mathematical formula. Why does that sound keep happening? Okay, you better stop right now. The formula problems we've been doing until now, you have a little mathematical formula and you substitute and you solve. And that's the right way to solve those problems, but these are different. So let's say we have something that is like my keyboard. We'll say it's 25 centimeters long. Let's measure it just so that we have an exact value. I'm going to use my meter stick. It is much more than 25 centimeters. It is 38.71 centimeters long. So we have a keyboard that is 38.71 centimeters long. Okay, are you with me so far? Hey, everyone better be writing this down. Step 1 is write down the given. Write down the given measurement. Step 1, write down the given measurement. If I use the word given, measurement is implied. Given is an adjective describing this. Are you aware, does Mr. Sinley sometimes use the word given to mean the quantity you are given to start out a problem? Well, I do, so that you better get used to that. Write down the given. This is the given, 38.71 centimeters. In this case, I have given it to you, but I have measured it myself. So the given measurement, 38.71 centimeters. Next step is draw a little conversion bar. What mathematical operation will this conversion bar probably be? If I'm going to put numbers up here and numbers down here, what mathematical operation is this? Well, two people said two different things, and one of them is right. Let's all agree upon the right answer. Let's try one more time. Division. This little fraction bar represents division in algebra. Okay. Step 3. Input units so they reduce to 1. Some of these cowboys are going to use some other phrase for reduce to 1. What do you guys sometimes call it when you have two things like this over this and what is that called? Yeah. Mr. Stintley does not like that. He does not like when you say drop out. I used to call them this, and then Mr. Stintley says that he prefers when people say reduce to 1, so that's what we call it here. Anything divided by itself is 1. And so we put in units such that they reduce to 1. Meaning, if a unit in the given was in the numerator, put it in the denominator. Are you familiar with these terms for fractions? So the unit that I was given, it's not written here, but is this in the numerator or the denominator? Well, you better be paying attention. This is the numerator, because this is the same as what? What fraction is this the same as?
2/3.
No. Oh, wow. But the 1 is where? If we write it in this way, which is true, the 1 is where? The denominator. So that means that our unit is in the numerator, okay? So this says, if a unit in the given was in the, this is an example, by the way. This is not like part of the, it is part of the rule as that's an example, but if a unit is in the numerator, or in the given was in the numerator, where's this one? Try again. So it's in the numerator. The unit in the given was in the numerator. Where should I put it to reduce it to 1? In the denominator. So it goes down here. Okay? Let's say I want to find out how long this keyboard is in inches, okay? So it was measured in centimeters, but I want to convert it to inches. So now I put, and this is still part of step 3, I'm going to put desired unit. Put desired unit on the same side of the bar as you want it. So where I want my new unit, remember I want to find it in inches, I want my new unit to be in the same place that I eventually want it to be. So do I want my new unit to be in the numerator or the denominator? The numerator, because when I just have a regular old number without a fraction bar or anything, that's the numerator. So I want it in the numerator. So I want inches in the numerator. I really, 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 this is not gonna come up quite yet but you guys need to practice. But when you're practicing, I really, really like it this way. Given step 1, 2, the conversion bar. Step 3, put in your units. Hunter.
Aren't centimeters in the imperial system and metric?
No, they're just in what we call the SI.
Don't we use them, like,
Rarely, and yeah, we use them, but hopefully we use them more. Anyway, step 4 is write. Let me put this. Instead of saying write, I'm going to put input conversion factor equal to 1. This is extreme. This is the most important part and the part that people screw up the most. This fraction has to be equal to, what did I just say? 1. It has to be equal to 1, because if I multiply this by what's equivalent to 1, am I changing the value at all? No, it's not changing the value. So I say to myself, in my brain, you can say it out loud if it helps you, but in my brain I say to myself, in 1 inch, there are 2.54 centimeters. And you might as well just memorize that now. You have to have that memorized. You must have that memorized. In 1 inch, there are 2.54 centimeters. You might as well write that down. Remind yourself, what does this mathematical operation here represent? This represents division, but these two numbers have to be equal. The operation here is also that they are equal. Why? Why do we want something that's equal to itself on this fraction? Tell me, Hunter. Stop doing that and tell me, why do we want this fraction to have equal things on top and bottom, the numerator and the denominator? Yeah, it has to be 1. This conversion factor has to be equal to 1. We don't want to change what the value is. We just want to convert its unit. And then finally, step 5. I'm going to pick a different color here. Brown. Finally, step 5. Multiply given by everything. This is step 5. Multiply given by everything in the numerator and divide by everything in the denominator, including, in big old letters, including units. Let's do the units first. What is centimeter divided by centimeter?
1.
Yeah, it's 1. So those reduce to 1. So we reduce them out. Look, so do that. Show that every time. What unit am I left with? Inches. So just inches. So what unit am I going to have here in my answer? Inches. Now I do the math part. What's 38.71 times 1? 38.71. What's 38.71 divided by 2.54?
38.71. That's
15.24. Okay, 15.24. So roughly, actually very close to 15 and a quarter inches. 15.24 inches. This is going to take some self-reflection that freshmen generally aren't good at. But why is this a useful way to do it? What are our alternatives? In the olden days, the alternative was just you have to remember that centimeters are smaller than inches, so this inches number should be smaller than the centimeters number. The current way to do it is you say to Google or Siri, how many inches is 38.71 centimeters, and that's fine. You can use that to check your work, and in fact, you'll probably use that most of your life. But how is this a useful method for you to do this? What primarily is this helping you with? No, it doesn't help you with the math. The math would be easier if you just wrote 38.71 divided by 2.54. This should help you with organizing. What this is an organizational technique, and this one is super easy, but they are not always super easy. And what this leads up to is there are some very difficult things. extremely difficult things that we do in chemistry and physics that would be very difficult without this method. And so we learn it now when it's easy and you guys barely know anything. And then when it gets difficult, you know the right way to do this and you don't have to worry about it anymore. So listen to me. I understand that this seems like a lot of work for this little answer, but that's not the point. There are two reasons for that. One, doing the work is helpful to you as a human being. I truly believe that. Two, it's not really about finding how many inches are in 38.71 centimeters. It's about practicing this method so that when you do actually have to use it, you're good at it. You don't have to work very hard to figure it out then, because it does get much more difficult. This is a normal basic unit conversion, converting from one unit to one other unit. Do you have questions about how to do this? What's the point? Yes, to help you organize, to get from one unit that you've been given to another unit that you're supposed to find it in. There are 3 other methods that you have to learn for this. They're chaining these. There are rate ones where some of the units are in the denominator, and then there are exponent ones. And we'll get to those later, but for now, we're just gonna stick with this for the time being. I'm gonna stop the video so that we can do some practice ones, and then we'll continue this tomorrow. Do you have questions about just this basic one? Are you sure? I really want to hear your questions if you have them. Okay.